All right, so today our objective is that you know what a ratio is, what a rate is. You can determine a ratio and a rate, and you can solve a proportion. So today starts our chapter on proportional relationships. So today we're talking about ratio and rates. If you have not already, these notes are on Schoology. You can go ahead and print them, fill them out as we go. If you don't have a printer, that's fine. Just make sure you take notes as we go. All right. So a ratio is a comparison of two numbers. A comparison of two numbers that can be written in three different ways. Those three ways are, so let's say we're comparing A to B. So A colon B, A to B. It's all said A to B. A to B, A to B as a fraction, so colon, fraction, or a word, A to B. And those of you who have me last year, I do remember we did at least hit on this. I can't remember. We hit on it. We spent some time on rates and ratios. We definitely know we covered rates and ratios. I don't think that we went as far as we will today, but we did rates and ratios. All right, so A to B, A fraction B, A to B. But all of them are A to B. I'm just moving it. A to B, A colon B, A to B. All right, so the order in which you write the ratio is important, because when it says you're comparing A to B, I put 5 to 2. I'm assuming 5 is A and 2 is B. It has to stay in the order that you said it was. Okay, and ratios like fractions can be simplified in the exact same way. You find a common factor. So if you had 4 to 12, what can I divide both of those by? What can I pull out of both of those? 4 is a factor of both of those. So 4 to 12 could be simplified 1 to 3, or 1 to 3, or 1 to 3. So they can be simplified, and when they say like fractions, they mean exactly like fractions. All right, so now we're going to use these pictures to practice writing ratios. So on our first one, we have teeth to no teeth. So I have 1 teeth, 2 teeth, 3 teeth, 4 teeth, 5 teeth, 6 teeth, 7 teeth, 8 teeth, 9 teeth. So 9 teeth. And I'm going to write this small in case I have to simplify it. So 9 teeth, 2, I'm going to do a colon. I'll mix it up a little bit. 9 teeth to no teeth. Well, they either have teeth or they don't. So let's figure out how many I have. And let's take away what was not there. So if I have 24 in all, because I have 6 rows of 4, it's 24. I know 24 minus 9 is going to leave me with 15 that don't have teeth. All right, I could count them out. But I know there's 24, and I took away the 9 with teeth, so that leaves me with 15 with no teeth. But I can simplify that. I know I have a factor of 3 in both of those. So I can go ahead and say 9 divided by 3 is 3. 15 divided by 3 is 5. So teeth to no teeth is 3 to 5. All right, so let's go ahead and do smiles to total. Well, let's erase what I have. Some of these teeth are not smiles, so we know it's going to be less than 8. So he's a smiler. 1, 2, And some of them aren't teeth. 3, 4, 5, not him, 6, and 7, 8. So I have 8 smiles. We already just said we have 24 in all because we have 6 rows of 4. So 8 to 24, which we know we can simplify by a factor of 8. So 8 divided by 8 is 1. 24 divided by 8 is 3. So smiles to total is going to leave us with a ratio of 1 to 3. And after this, I'm going to use a different way to write it because we know there are 3 ways to write our ratios. All right, let's say we were doing our big I's to teeth. Well, we have already counting our teeth, so we know the second part is going to be 2, 9, because we already said up here there were 9 teeth. So let's see how many of them have big I's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I didn't miss any. So 12 to 9. Big I's to teeth. And you see how I did teeth first, but I made sure I put it in the second position because it's eyes to teeth. If I put it in the opposite order, we'd think that there are 9 eyes because they told us to do eyes to teeth. So I have to put 12 eyes to 9 teeth. And then we can go ahead and simplify. I know I can pull a factor of 3 out of both of those. So 12 divided by 3 is 4. 2, 9 divided by 3 is 3. 4 to 3. All right. So in my next one, we have smiles to tongue. All right. So smiles to tongue. Well, we already counted 8 smiles up above. So 8 smiles to, let's see how many tongues we have. 1, 2, 3, 4. And that's it. I have 8 smiles to 4 tongues, which I can simplify by a factor of 4. 8 divided by 4 is 2. Bring down our 2. 4 divided by 4 is 1. So 2 to 1, 4 to 3. All right. I'm going to erase this part so you can read it if you're copying notes as we go. Now I want you to go ahead and pause this. I'll erase any markings I might have made because I want you now to pause this and do the last 4. Figure out how many of each you have and then simplify them. You might even make some of them fractions because I haven't done any fraction ratios yet. All right, have you done it? Then pause it. I told you to pause it and do it. You look silly not doing it. All right. So by now, you've had time. You've paused it. You figured them out. So, we just figured out that there were 4 tongues in this last one. So 4 tongues. And we already also figured out that there were 24 because there are 6 rows of 4. So 4 tongues to 24 in all. All right. And then we can simplify that by a factor of 4. 4 divided by that factor of 4 is 1. 24 divided by that factor of 4 is 6. So our ratio is 1 to 6. Did you get that? Awesome. If you didn't, do you see what you did? Was it just you picked out the wrong factor or you didn't simplify it? All right, so angry to smiles. Well, we already did smiles. We said there were smiles was 8. So I'm going to make it a fraction this time because I haven't done that yet. Angry on top, angry to smiles. So now let's see how many how many angry faces there are. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I see 10 angry faces. So we have 10 angry to 8 smiles. Well, and again, angry 2 smiles, top to bottom. Angry 2 smiles. I can go ahead and simplify that. I can pull out a factor of 2 out of both of those. So 10 divided by 2 is 5. 8 divided by 2 is 4. And our end ratio is 5 to 4. All right. Now let's go ahead and do silly face to angry face. And I'm going to deem these little guys silly face. I guess maybe that could have been another issue in our ratios, was if you deemed certain faces silly that I didn't. I did these guys as my silly faces. So these are my silly faces. So I said silly to angry. So I have 2 silly. And we already said angry up here was 10. So 2, 2, 10. And I shouldn't have wrote that so big. Also, I want to write it as a fraction. We did some 2, so we did some colons. We didn't do any fractions. So 2 silly faces to 10 angry fraction, or 10 angry faces. We're going to divide both sides, both of those by 2. 2 divided by 2 is 1. 10 divided by 2 is 5. And I've simplified my ratio. And then let's do our last one. I have tiny eyes to smile. Well, did we do tiny eyes? I think we did smile, but not tiny eyes. All right. So for tiny eyes, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so that looks right. So I sit 10 tiny eyes. So tiny eyes to smile. Tiny eyes. 2, we already said smiles was 8. So 10 to 8 would simplify. Oh, shoot. Miss Hildebrand learned to read. Tiny eyes to no smile. There were 8 smiles. There were 24 in all. So there's 16 not smiling. So 10, we counted 10 tiny eyes to no smile is 16. Pull out a factor of 2. So 10 divided by 2 is 5. 16 divided by 2 is 8. 5/8 is our ratio. Awesome. So a rate is a specific comparison. A rate is a type of ratio, specific comparison of 2 quantities with different units. So for example, miles per hour miles per gallon, so mph, mpg, dollars per ounce, that dash means per, dollars per unit, dollars per sweater, etc., etc. All right, so it tells us Hunter jogged 4 miles in 30 minutes. Ryan logged 7 miles in 48 hours. What is each person's rate speed? Who jogs the fastest? So I have 4 miles in 30 minutes. I want to know how many miles he travels in 1 minute. So miles per minute. We're going to go ahead, and in order to get our unit rate, we have miles per 30 minutes, but I want miles per 1 minute. So what I'm going to do is I'm going to say 4 over 30, but I want to know how many miles in 1 minute. So what I'm going to do is something called the butterfly method. I'm going to multiply my diagonals. So 4 times 1 is 4, and x times 30 is 30x. So 4 equals 30x. And I want to solve for 30. So if you look, we're going to end up back with 4 over 30 equals x. But they won't always be in the right order. So I just want to make sure that we've got it. So 4 over 30 is equal to x. So what we're going to do is divide that out and say that, who is this? 4 over 30 is Hunter. Hunter, once I divide that out, x is going to be equal to 0.13 repeating per minute, miles per minute. I'm just going to put MPM, miles per minute. All right, so we are going to go ahead and do the same thing with Ryan. Ryan, it tells us, runs 7 in 48 minutes. And again, we want to know how many in 1. So 7 times 1 is 7. 48 times x is 48x. We're going to divide both sides by 48. X is going to be equal to 7 over 48. And when we divide that out, x is going to be equal to 0.146. So it asked us what their rate is. That's Hunter. That's Ryan. Who goes further in a minute? 0.1. They both have 0.1. After the one, I have a 3. This one has a 4. Ryan runs faster because he gets further in the same amount of time. All right. You got that? Pause it if you don't, because I'm going to move on. Awesome. So now we're going to talk about the unit rate. Have you ever gone to the store? And I use unit rates actually a lot when I go to store. So possibly, like in this first example, they give you a 12-pack of Orange Crush is $3, but a 6-pack is priced at $1.75. A lot of times, you might think to do this, you might not. Your parents might do it. I figure out how much it's going to cost me for one, because sometimes you assume that the bigger pack is going to be cheaper per soda, but it might not be. Sometimes it's cheaper to get the smaller pack, but you got to figure out that unit rate to determine that. So if I want to figure out my unit rate, I'm going to say that I have a 12-pack of Orange Crush priced at $3. So 12 for $3. I want to know how much it's going to cost per one can. How much is one can? So we're going to go ahead and do our butterfly. So 12x equals 1 times 3 is 3. And then we divide both sides by x to isolate, or divide both sides by 12 to isolate x. And our cost of one soda, because soda to price. So 12 cans for 3, 1 can for how much? So x is the price of 1 can. So x, or 1 can, is going to be 3 divided by 12, which can simplify to 1 over 4. And I know you might have to divide it out, but I already know that 1/4 is going to be 25 cents a can. So that's how much it is in a 12-pack. So we're going to go ahead and do the same thing. It tells us a 6-pack, so 6 sodas, is $1.75. So soda cost. So how much is one soda? So 6 sodas to 1 soda. How much is the cost of one? So again, we're going to cross multiply. So 6 times x, 6x, 1 times 175 is 175. We're going to go ahead and divide both sides by 6 to get x by itself. And the cost per soda for 6 sodas is I got 0.291 and it kept going. But I know that dollars only go out to the hundredth position. So I'd round that cent and one doesn't round up. So for 6 cans, it's 29 cents a can. So for 6 cans is 29 cents per can. And for 12, it's a quarter per can. Go ahead, pause this and fill that out because I've written into this next part. You got it? Awesome. So it says when two ratios are proportional, I did that backwards. When two ratios are equal, they can be referred to as proportional. All right, so I'm going to explain 2 different ways to solve proportions. So I'm going to go ahead and give you a proportion. So let's say this is our proportion. X to 4 is equal to 9 to 12. Well, the first way I was just showing you just now to find unit rates. We just had to set up our own proportions, was to multiply our diagonals. That's the butterfly method. So x to 4 equals 9 to 12. So multiply your diagonals. So 12x, 9 times 4 equals 36. We want x by itself. We're going to divide both sides by 12. This cancels, and x is 3. Well, that's solving by cross multiplication. What if I told you this is a proportion? This is equal to that. So what I want to know is 4 times what gave me 12? 3 times 3. Well, so what if I wanted to go backwards? What's my inverse of multiplication? Division. So if I divide by 3, 12 divided by 3 is 4. So going backwards, we can divide. 9 divided by 3 is 3. Did we get the same answer? Yes. So scaling would mean that I want to figure out what that factor is to go to my second one to determine a proportional fraction. Scaling isn't always possible because it might not be times the same number, so you might not be able to tell. So let's say I had 3, 6, and something over 12. These are equal. Well, I know 6 times 2 gives me 12. So 3 times 2 is going to mean x is 6. So I just figure out that I have to multiply both by 2. But if this isn't a number that 6 evenly divides, that's when this butterfly method may be simpler. All right, so I've got one more for us, and it is a word problem. It says a small university enrolls in in-state and out-of-state students. The number of students enrolled in their most recent freshman class was 243. So total 243. The school reported that it enrolled 7 in-state students for every 2 out-of-state students. So 2 in per 7. I did that backwards. 2 out per 7. Right. So 2 out per 7 in-state. How many of each type of student was enrolled in the freshman class? What I need to know is just this. How many of each? So what I'm going to want to do is set up a proportion. Here's what I can do. I know out. So 2 per 7. So 7 and 2 give me 9. So if there are 9 kids total, because 2 out and 7 in is a group of 9. So we're talking about a group of 9. But out of the 9 of them, 2 are out of state. I want to know how many of them are in all, if we're talking about the whole. So a group of 9, for every 9 students, 2 of them are out of state. So total. So if the total students is 243, how many of them are out of state? So I'm going to go ahead and do my butterfly method. Because I know for every 2 out of states, there's 9. So how many out of states are there in the 243? So I'm going to go ahead and multiply 243 times 2 to give me 486. And x times 9 to give me 98x. We go ahead and divide both sides by 9. And then I know that x is going to be 54. All right, so then I can go ahead and do the same thing for the other one. That's my answer. All right, so then it tells me the same thing. So again, our sample group is 9 students because there's 2 for every 7. So that's 9 kids in all. 2 out, 7 in. Well, this time there's 7 in for every group of 9. But there are still 243 at the school. So in a group, in any given, well, not any given, but in a group of 9 kids, 7 of them are going to be in state. And 2 out, which is a group of 9. So 7 of those 9 kids are in state. So how many of those kids are in state from all of the kids if this is proportional? So we could figure out that 243 times 7 21, 28, 30, 14, 17. So I have 1701. Divide or multiply my diagonals equals 9x. I'm going to divide both sides by my 9. And in the total campus, if a group of 9, every 7 kids were, the total of all of the in-state kids at this school is going to be 189. So not x, because All right. So today we talked about a couple of things. A ratio being a way to compare two numbers, two different ideas or objects or things. A rate being a specific comparison with different units, miles per hour, miles per gallon, such and such. We talked about unit rates, figuring out how much per one. I showed you how to solve them using a proportion, which ended up with us dividing them out. Then I helped you, this is your rate. Then we talked about unit rates, where we figured out the value of 1. We talked about how to solve a proportion, butterfly method or scaling, and we said scaling really only works if one goes to the other evenly. So 4 to 12 is 3, 6 to 12 is 2, but what if I had 4 to 9? I can't do that evenly, so the butterfly method would work out better. You're going to multiply your diagonals. So 2 times 24 gave us 40, or 2 times 243 gave us 886 equals 8/9. You set one diagonal equal to the other diagonal and solve it like an equation. So that's what we talked about today. That covered our entire objective. So make sure when you submit these notes, you go ahead and include the part about today's summary. I just really told you a lot of it. So tell me in your own words what you learned and how to do those things, which were our objective. What a ratio is, what is it? What a rate is, what is it? How do you determine a ratio or a rate? What about a unit rate? And how do you solve a proportion? And what 2 ways? All right, that is all I have for you. If you feel like you can do this homework on this, go ahead. It's on Schoology. If you feel like you need help, definitely come to our guided practice. I will see you guys at guided practice. Have a great day.